It is given that the root of 11 minus root 120 divided by the root of 11 plus 6 root 2 is a root 6 plus b root 5 plus c root 3 plus d root 10. I need to find the value of the sum of a, b, c and d. Extremely interesting problem. So the left hand side, root of 11 minus root 120 divided by root of 11 plus 6 root 2. I could write this as the root of 11 minus root of 4 into 30 divided by the root of 11 plus 6 root 2, which can be written as the root of 11 minus 2 root 30 divided by the root of 11 plus 6 root 2. Now, it would be very interesting to identify how we can simplify this. Let's take a look at the numerator. 11 minus 2 root 30. If I can bring it in the form of a plus b the whole square, that would be interesting. So, I can split 30 as 6 into 5. So, this thing can be written as 6 plus 5 minus 2 into root of 6 into 5, which will be equal to root of 6 square plus root of 5 square minus 2 into root of 6 into root of 5, which ultimately can be written as root 6 minus root 5 the whole square. Very interesting. Similarly, if I take the denominator 11 plus 6 root 2, that is nothing but if I take 11 plus 6 root 2, that is 11 plus 2. I take the 3 inside. So 3 square 9, 2 root 18. So 18 can be split as 9 and 2. So I can write this as 9 plus 2 into root of 9 into 2, which is nothing but root 9 the whole square plus root 2 the whole square plus 2 into root 9 into root 2, which is root of 9 plus root of 2 the whole square. Hence, now let's go back to our sum. I can rewrite this as the square root of root 6 minus root 5 the whole square upon the square root of root 9 plus root of 2 the whole square. The root sign and the power of 2 take care of each other. So this becomes root 6 minus root 5 upon root 9 plus root 2. Right? So I can simply write this as root of 6 minus root of 5. I multiply and divide by root of 9 minus root of 2. Remember, a plus b into a minus b can be written as a square minus b square. So I'm multiplying, dividing by this. My equation becomes root 6 minus root 5 into root 9 minus root 2 divided by 9 minus 2, which can be replaced by the pure number 7. So if I now expand root 6 minus root 5 into root 9 minus root 2, I can write it as root of 54 minus root of 12 minus root of 45 plus root of 10 the whole divided by 7. Root of 55 is 9 6 are. So I can take root 55 as 3 root 6 by 7. Root of 12 is 2 root 3, the whole thing divided by 7. 45 9 5s are is 3 root 5 divided by 7, and root of 10 I can simply keep it as root of 10. Now if I compare it with the given terms a root 6 plus b root 5 plus c root 3 plus d root 10, then I get the value of a as 3 upon 7. I get the value of b as minus 3 upon 7. I get the value of c as minus 2 by 7, and I get the value of d as 1 by 7. So when I add these four terms, a and b cancel out each other. Minus 2 by 7 plus 1 by 7 will give me negative 1 by 7. So option B, minus 1 by 7, is the answer to this particular question.